Good morning to all. This is Dr. Shanna Montu, Assistant Professor in Mathematics, Government First Grade College, Jevargi. In this video, we have to go for the learning of the examples that related to the interval 0 to 2L. Already we know that the forms of a or the Fourier series equation and their coefficient, which is in terms of the 0 comma 2 pi. In the same manner, we have to go for the Fourier coefficients of the Euler's formula related to the interval 0 comma 2L. Before going to solve the examples for the interval 0 comma 2L, we should know about the Bernoulli generalized rule of integration by parts and the derivative, the integral part of the e to the power of ax cos bx dx, as well as the integration of e to the power of ax sin bx, and we should know about the sine of n pi, cos n pi, as well as cos of 2n pi and cos of 2n plus 1 of pi. These are the some results that are useful for the finding the Fourier coefficient a0, an, bn related to the Fourier equation for the interval 0 comma 2 that occurs in the examples. So for that, now we will go for the example, that is Fourier expansion of f of x is equal to e to the power of x, and where x lies in between minus 2 to 2. So that means the interval which is in terms of minus L comma L. So here L is equal to 2 by comparing equation or the interval to the interval minus L comma L. So that is 2L is equal to 4, that implies L is equal to 2. So a0 is equal to 1 by 2 integration of minus 2 to 2 f of x dx. So that means the a0 value is 1 by 2 integral of minus 2 to 2 f of x, they are given, which is equal to e to the power of minus x. On integration of e to the power of x, we know that the integration of e to the power of x is e to the power of x, and if the x part is a x form, then we will get it is divided by of a. So for that, the a0 is equal to 1 by 2 times of minus e to the power of minus x, and which is running from minus 2 to 2. After applying the lower limit as well as the upper limit to the obtained solution, so that means it is equal to minus 1 by 2, because minus take it outside, and that is equal to minus 1 by 2 e to the power of minus 2 to minus e to the power of 2. So that is equal to 1 by 2 e to the power of 2 minus e to the power of minus 2. So that is equal to, we know that e to the power of x minus e to the power of minus x divided by 2 is equal to sine hyperbolic function of 2x. Using that, x is here equal to 1. So that means the value which is equal to sine of h2. In the same manner, the another important Fourier coefficient is an, and that is equal to 1 by 2 times of, that is we know that the formula is 1 divided by L integral of minus L to L f of x cos n pi x divided by L into dx. And we know that L is equal to 2, so that is the interval is running from minus 2 to 2. So n is equal to 1 by 2 times of the integral minus 2 to 2 e to the power of minus x cos n pi x divided by 2 into dx. So 1 by 2 as it is. Using the Bernoulli rule, the first function or we this is not in terms of the what we can say that the Pipard's rule, but is one of the most important result, that is integration of e to the power of ax cos bx dx is equal to, we know that it is e to the power of ax divided by a square plus b square into bracket a cos bx plus b sin bx. Using that rule, we have to write here a is equal to minus 1 and b is equal to n pi divided by 2. Using that, we can write it is e to the power of minus x divided by a square plus b square is a is minus 1 whole square is 1 and b is equal to n pi divided by 2 whole square. Using that, we have to write it is minus e to the power of minus x divided by 1 plus n pi divided by 2 whole square. In the bracket, a is equal to minus 1 cos n pi x divided by 2 plus b is n pi divided by 2 into sin n pi x divided by 2, and which is running from minus 2 to 2. And that values is equal to, after applying the lower limit as well as the upper limit and on substitution or on solving the obtained, we will get it is an is equal to 4 times of minus 1 to the power of n sin hyperbolic of 2 divided by 4 plus n square plus pi square. In the same manner, the another coefficient, the Fourier coefficient is bn, and we know that their value is minus L integral of minus L to L e to the power of, that is f of x into sin n pi x divided by 2. F of x is e to the power of minus x and sin n pi x is divided by 2 as it is, and here L is equal to 2 and the limit is running from minus 2 to 2. Using the same, the integration of e to the power of ax sin bx dx is equal to e to the power of ax divided by a square plus b square into bracket a sin bx minus b cos bx. Using that, we can write it is a is equal to minus 1 and b is equal to n pi divided by 2. So that means bn value is equal to 1 by 2 times of the integral the bracket e to the power of minus x divided by 1 plus n pi divided by 2 whole square in the bracket minus sin, because n a is equal to 1, that is minus 1, sin of n pi x divided by 2 minus b is n pi divided by 2 cos n pi by 2 into x, and the whole bracket which is running from minus 2 to 2. After applying the upper limit as well as the lower limit, we will get the value of bn as 2n pi minus 1 to the power of n sin h2, that is hyperbolic function of the 2 divided by 4 plus n square pi square. After applying all the values of the function e to the power of x and their coefficient terms, that is a0, an and bn in the Fourier series, we will get it is as e to the power of minus x is equal to sin h2 divided by 2 plus summation n is running from 1 to infinity 4 times of minus 1 to the power of n sin hyperbolic function of 2 divided by 4 plus n square pi square into cos pi n x divided by 2 plus summation n is equal to 1 to infinity 2n pi minus 1 to the power of n sin hyperbolic of 2 divided by 4 plus n square pi square into sin n pi x divided by L. And these are the obtained Fourier equation of the function e to the power of minus x in the interval minus 2 to 2. and these are the some examples related to the interval, that is 0 to 2L, and some references that is used by me to solve the example.